Okay, we were implementing this, so we need to move the head up 1. So I think we need an optic for optics, and we want probably move the head. We probably want optics for this. Optics. Okay, so I can't decide if this is just working. So let's see if we can just use the optic. So what we need to do is create a new state. So it's like next state. And we're going to say basically day9 state dot. And if I understand correctly, this is just like we can build up an optic from this. So we want to say day9 state dot head, and then that'll get us a point. And in the point, we have a row. And we want to modify. I don't know how this works exactly, so we're going to have to think about this. I think it's modify. Okay, so we add that, and this gives us to modify. What do we want to modify? We want to modify the day9 state, and we want to do something with it, which is we want to subtract 1 from it. So something like this. And I wonder if we hit play, if it will do the right thing. Point cannot be added with optics. Okay, so let's fix this. So we can make a data class called point with a row, a call, and a grid dimension. And then instead of like these is top rows, we can create a function for point dot is top row, and it doesn't really need anything. I think we could just say this row equals 0, and then that should like do the thing. Play. Day9 point I don't know what this means. Oh, I think I know what this means. It's like it creates. Oh, okay. So that's like the constructor. And then we have to create a companion object. So I think what happens is like when optics does its like code generation, it populates these companion objects so that we have like head and stuff. Okay, and then that works. So it just it doesn't like understand the compilation, and so I think that we need to like explain to it how to do that. And I think there's a way to do that. So let's see if we can figure it out. There was like a So like arrow, optics, code generation. I don't. This is where we were before, right? So optics DSL, optics for collections, single behavior, Prism, API docs. No, that's not going to get me there. What's media? No, this is not really what I want. Arrow optics setup idea IntelliJ. That's what I want. Data class reference. What am I doing wrong? Okay. Your Gradle configuration seems to be missing some of the required KSP setup. You can find it here. What's this? Yeah. Okay. Do. But I looked at this. I set this up. Oh, I see it now. Okay. Okay, so we want to go to build generated KSP main Kotlin here. And then there's a way to like add this somehow. Git? No. Optimize imports. Mark directory as... What does it say? Why can't I use that? Reason about... Mark the following paths as generated source roots. Okay, mark directory as sources root. And then it says one other path. Generated KSP main resources. Okay, I don't have that. I only have this Kotlin one. So what if I like just come over here and hit save? Okay, let me like restart IntelliJ. I really don't. I mean, I have no idea what it's going to do. Because seemingly it knows about these companion objects now. I don't really have... Okay, it seems to be loading. So fun point is bottom row. This equals... What is it? This dot grid dimension dot first. That would be the rows. And then fun point is left row. This column 0 point is right row or column. This call equals this grid dimension dot second. Okay. So we haven't used those yet, but we will. But this is not... Oh, maybe I need to like import it? I'm confused. I'm confuzzled. Build generated this one. Mark directory, sources root. And then we want day9 state. Conflicting declarations. Kotlin not configure. Configure. Maybe I don't do this? This was working before? Do I need to like just build this once maybe? Will it just like make everyone happy if I just like build the thing one time? It seems like think that this is not gonna work, so I kind of don't understand how to fix that. Let's see if there's anything else here. Okay, so may also be necessary to configure these directories in your KSB consumer modules build scripts. If you are using IntelliJ and KSB in a Gradle, okay, let's try this. So plugins. Oh, that's not here. That is somewhere here. Okay, so plugins, idea. And then down here, we will add this jam. Build generated KSB main colon. Okay, so I think it's gonna work. I have no idea. Oh, there it goes. Okay, so what happens now? Well, it runs, so that's something. The question becomes, is it happy now? It is happy now. Okay, nice. So that's a good way to deal with this, I guess. Okay, so now we've modified into this next state, basically like moving up a row if we're not already in the top row. So we have ahead is top row. That'll tell us like we're already in the top row. There's nothing to do. Or we'll have to like move up a row. And then the next question becomes, is the tail 2 rows away or 1 row away? So tail row is going to be day 9 state tail row get, I guess. Tail row get from next state. I get it. Okay. Because I have to, like, I've created an optic and I need to go grab, like, the thing. I don't know why that's unit. And so we also need head row, which is day 9 state head get, sorry, row get next state. And then basically if head row, well, the tail row minus the head row is 2, then we need to basically put the tail underneath it. So I think I just want the tail and the head. So if the tail row minus the head row is equal to 2, then we need to say that the next state, or sorry, day9 dot next dot tail dot modify next state. And basically we want to just stick the new value of the tail, which is the head. Okay, so that's a point. So we want to say the what do we want to do? We want to take the current position of the head and subtract 1 from the row. Yeah. Modify the head I think so. So basically the idea is okay, so if the tail is 1 row below, we're going to leave it because basically I haven't explained this problem at all, but we're talking about a movement where the head is this isn't valid. Okay, so in this case here, if we move the head up to this spot right there, then the tail snaps underneath it, directly underneath it. So it's actually we can't we're not subtracting 1 from the row, we're adding 1 to the row. I have my dimensions backwards basically. So H moves up a row. In this particular case, then T follows. It snaps into place. If H was here, however, and we moved up a row, then these two are only 1 different and it doesn't move. So it will only move if we up twice. So that's, I think, move up. And the tail will always be higher than the head, so we can say this, I think. Optics are nice. Okay, so I think that we now can write move down, except we can pretty much just copy and paste this and then just flip some signs probably. All right, so move down is going to determine if we're the bottom row. If we're in the bottom row, we have nothing else to do. If we... Okay, and then if we want to move down, we need to add 1 to the head. And then we'll get the head and the tail. And if the head is further than 2 positions, then we'll modify to stick the tail above the head. Like this. Yep, like that. Okay, next. Move left. Now we're going to mess with columns. So if we are the head and we've reached left column, there's nothing to do. Else, we need to modify the column to the left, which is in the negative direction, and do basically the same calculation. Tail minus head dot row. And then we modify the column to be column column +1. And then we need to create move right. And the optics are pretty nice here. Glad I figured that out too. Okay, so move right is right column. And then here we're gonna say column move right, which is in the positive direction. And then we need to flip this head row minus tail row. And then we're gonna modify the column in the negative direction, else this. Perfect. Okay, now we need to apply our movement. So we have our state and we have the thing that we want to do. This movement should be a movement. And so we should be able to say, that sounds really dumb. We should be able to say when movement is direction dot up. This is like movement dot. Okay. So we have a direction and a magnitude. So this is going to be direction dot up. And we basically want to apply like n the magnitude number of times. So we're going to say 0 until movement dot magnitude for each dot indices dot for each. Is that what it is? What's the thing here? Seems to think for each is a thing. So for each of these things, we're going to move up the accumulator. But we have to keep adjusting the accumulator. So actually what we want is a fold. We're going to fold on the accumulator. And we'll have an inner accumulator and an X, which we don't actually care about. We're just going to move up the inner accumulator that many times. And then we can just kind of like duplicate this code, I think. So this is like indices 0 until movement dot magnitude. And then that way we don't have to write as many things. We can just like indices dot fold ac. And then like we could move up it dot first. Is that like allowed? Probably not. I don't know how to be like just the first thing. I don't really know how to do partial things yet. Like that would be convenient in this case. Left indices fold ac x underscore move left x. And last but not least, we just need to go right, and move right. I have no idea if I got this right, so we'll have to see, but we have now the final state seemingly, and we've applied this many times. I think that sounds right. I don't know. Let's find out. Okay, so we have the head at 2-2, and we have the tail at 1-5. So no, it didn't work. Because that should be like next to it. Okay. So, do we stare at this code, or we just try and make like an example to see if it's working? What is this saying? What's duplicated here? How do I like close whatever I'm looking at here? Okay, so I think we should like reduce our movements and just start like working on that maybe. So let's start with day 9 and see if we can quickly figure this out or not. If we can't, then I'll probably like say, oh well. Okay, so step 1, let's just try and go right 4 times and see what happens. Okay, so okay. So that didn't work, which implies that like something is just straight up wrong with what I'm doing here. So we do move to the right, but the tail doesn't move. So like the tail needs to move as well. In this particular case. So in this case, we need to say day 9 dot tail dot call dot modify next state it plus 1. So there's basically 2 cases. The first case is these things are further apart, and so we need to like move things to the right, except in the case where where we need to do the snap. So this looks okay here. So we are at 0, 0. Actually, okay, this isn't right either, but we're getting closer. So if head row what? How did that do that? Okay. So if they're so one thing I didn't account for is like, let's say they're right on top of each other, then we only want to move the head. And so that would imply that they're like, this means they're, oh wait, no, it doesn't, because I don't have, we don't really want to know that the next state okay, so let's see here. So if we're in a situation like, it's hard to draw. So the head and tail are like this. If I move this one space over. These are on top of each other. If I move it one space over, then the distance between them is 1, and I should not move the tail. So there's kind of like 3 cases. So the first case is like they're on top of each other. So let's do that first. Okay, so if head.row minus tail.row equals 1, that means these things were on top of each other. And we can just put a comment here. So H and T were on top of one another. Now, the other thing I don't recall is like if we're on the right side, is the tail go in or no? Not sure. So if this was the case, then we don't do anything. Okay. If head.row minus tail.row equals 2, then H and T were not on top of... Is this right? I think they always end up they always snap in the case where this is true. This is the case. So I don't really want to delete that code. What I want to do is just grab this and say that. Then delete all this. Okay, let's just check this. Okay, so that's that. Now, the question I don't understand yet is do we push, like if we push the H against the wall? Yeah, if we do this, we're gonna snap. If T was here, we would just move it up. So it's like the same thing. This one is like weird. Okay. Well, the distance would be 1 in that case, not 2. So we leave T. Distance 1, leave T, then we snap. Do the H and the T ever... Okay. So this is a case where we move H and then it's 0. And in that case we also need to we need to like not do anything. So I think what we should do is say when head.row minus tail.row is 0 or 1, then we have next state. Else we have this, I think. Again, we're kind of like working on one of these at a time because I think it's like actually pretty hard. So this can all go away. Okay. Nope. Oh, this is hard. Okay. So we move the thing 1, Then we subtract them. The head is smaller than that. That gives me 1. So I move the thing. I feel like I just want to know. Maybe I don't want to know the relationship after. I want to know the relationship first. If they're like diagonal. Or what do I want to know? I don't even know. I've kind of checked out on this. This is clearly not enough information, right? Like, what I need to know is like their relationship. Maybe what I want is like, I want to know if we're moving lateral. What do I want? Why is that thing blinking? I don't think the camera was blinking this whole time, but it's blinking now. What are you doing, camera? So what I want to be able to do is move left and then basically deal with this situation. Where is it? This one. So we should be able to move right, left, and then end up in this situation. That's what we're trying to do. Let's just focus on right and left for a second. But there's like so many different states that we can end in. Like if the T is here or here. Then we're fine. Like then it moves. And it's going to always move behind the H. So what do we need to know? Oh, so okay, if we had an H here and we moved, it would be negative. That's the thing. So if it was negative, then we literally wouldn't move. Okay, so H is here. Well, we got to do it the other way. So H was here and T was here. We're moving right. That's the point. So if I take head minus this, I get a negative number. And if I get a negative number, then I'm next state. Maybe. I don't know. Let's try this. And then if... What does this do? I think this moves... Okay. Okay, let's fix, quote unquote, fix move left. So move left is going to be very similar to this. I think. Just delete this. And then this is -1. And then tail. Head row. And then this becomes plus, I think. So what we want to do is move right 2, left 1, and see what happens. We should end up on top of one another. I need to print like all the intermediate states. So also println it. Okay. This is very hard, by the way. We also want to println initial state. And for now, let's just remove this because we're going to print the final state as well, so we don't duplicate that row. Okay, so we start with the initial state. We move right. The head moves one column over. The column does not. We move again. The head moves, and sorry, the head moves and the column moves. Nice. Then we go left. This decreases, but this snaps. So it would have been 1 minus 1 is 0. I feel like I can't rely on this head minus... Like, I need the first... I need to compare the first state, not the next state. Okay. This is actually pretty hard. So this accounts for... Okay, so 0, 1, 2, 1, 1. Okay. So if we R3, L1, R1, it should be exactly as if we did R3. So, so R, L, R. Okay, cool. So that looks right. Now let's reduce this and say we're starting at 0, so we need to go down 3. Also, I think I have the up and down directions inverted, which is a problem because I'm starting at 0. And so when I say down, I think it means I'm incrementing numbers. I'm starting in the bottom left and they start in the top left. So I need to invert my down and ups. So let's say I go down 3 and up 1. It's going to be a very similar situation. So we need to delete all of this code and all of this code and kind of like replace it with the up-down version of this. Okay, so if we move up, we need to... Oh, actually, I think I have it like I have the code working directly, but correctly, because like moving up implies we're heading towards the top, which is decreasing the integer. So I think I am actually okay. Is that right? No, because this is the starting point. So this is 0. So if we move up, we want to increase. So yeah, I want to flip this sign. So we want to increase our z direction, or increase our row direction. Oh, I also have rows and columns flipped, don't I? Because moving left and right is a column change. Oh no, I'm right. I'm being stupid. Sorry. Okay, so we're moving up. That's the next state, and then we want to say basically the inverse of. So head. We want to invert this. I think head row minus tail row, and then I think we want to do this. And okay. So if we're the tail and we snap, we want to be below. So this needs to be row. Okay. So that's up. So let's copy this, paste it here, and then we need to invert these. I think. Okay. Oh. I meant to say up 3, down 1. Also, I need to fix the up and the down. Okay, let's see here. So we don't do anything? So we modify the row. And then we get the head, which should be row 1. And then we say 1 minus 0. Oh. We're now like talking about columns. I guess. Okay. Something's drastically wrong here. It's just doing nothing. Oh, because we're already at the top row. I have this backwards. So this is this dot grid dimension dot first, and this is 0. Okay. So we want to go up 3, down 1. And then we need to move down to columns. So up 1, 2, 3. Our tail doesn't follow at all. And then we go down. So this is doing the right thing in the point, but our tail is not following. So let's think here. So we start at 0, 0, and we go up 1. We want to take... Wait, how does this work? Our column will always be 0. So our head row Okay. So we subtract the head dot row. So that's like also -2, isn't it? Head row minus tail. Shouldn't you snap? I don't understand why this isn't snapping. Oh. Okay. I don't know. This seems to be doing something. So can we stick these in here and get the right answer? I have no idea. So 0, 1, 2, 2, 0. Well, these are the columns. So 0, 1, 2, 1. Okay, that looks right. So that's something. Okay, and then basically the last step of this is we just want to add the resulting tail. So the empty set is not really correct because it's actually set of 0 to 0. So you always see that first set. And so what we want to do here is say, okay, we've made an adjustment, and then we want to also adjust the set. So we're gonna say what? I don't know, something. Let's move this here, and then like that. Okay, so we have an accumulator here, which is a day 9 state. So we're gonna say day 9 state dot the scene tail dot modify it, and we're going to set add, or no, we're going to, we have the set, and we're going to add it with we don't have a mutable set. So I think we just do set of, and then the tail. We can probably just make a function for this, because I don't want to write this whole thing out. So we're going to say function add scene tail, and we're going to get a day 9 state, and we're going to return a day 9 state. And basically we're just going to say also, oh, not all of this, maybe all of this though, and this, add scene tail it. Okay. So, this is going to say, we're going to take the day 9 state scene tail, modify. We're going to have a set, and what we want to do is add that to the day 9 state scene tail. No, tail. We have seen basically this pair. And so we want to then, oops, what the heck? I don't know if there's a better way to do this. So like, if we had a mutable set, we could say s.add, but like, I don't really want to do that. I just kind of want to add these sets together, I think. Okay, and then here we can say add scene tail. Add scene tail. Okay, this clearly doesn't work the way I was expecting it to. So I think we want to say, So we get the next state, and we want to modify the next state. And we want to say, oh, I guess we can just do the thing here, right? So we had seen the next state, and so we want to modify this to say set of scene. Move up. Next state. Modify the next state with that. Okay. I think that's better. I feel like don't love this code, but I don't really want to think too much more carefully about it right now. Kind of tired. So we'll just copy this. Paste. 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 And move up. Move down. Left. There we go. So those are all the things we've seen. And so what do we want? There are 13 positions. How many positions is a tail? Okay, perfect. So this is going to be dot scene tail dot size. And that should be 13. It's 14. Why? I just assume that I'm doing something really dumb here. Ugh. I don't really want to work on this anymore. I'm kind of tired. I just assume that this grid is wrong. Or like not this grid, like my grid is wrong if I were to plot this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And I have 14. What are they again? Okay, so 0, 0, 0, 1, 0, 2, 0, 3. And you can see here I have 0, 4. And that's not 1. So this is 0, 1, 2, 0, 1, 2, 3, 4. So basically when I moved up, I snapped is what that means. So when the head went from here, so it was like tail, head moved up, but the tail snapped. And that's that 13. So this is 1, 4. 1, 4. 2, 4. 3, 4. 3, 1. I don't think the order is like in the set matters. So this is 3, 1. 3, 2. 3, 3. 2, 5. Yeah, something's really jacked. 2, 0 is like this one. So yeah, I don't know. Something's wrong here. These problems are very hard. I just assume like we've like, I assume there's like some edge cases here that I'm not considering, and I think it's related to the snapping, and if we just didn't have the snapping, it would be so much easier. Well, it really wouldn't. So the only time we can have the snapping is when we're 2 away. Is there also a case where there's... Is it like this one too? What does this do? Oh, well, this was just -1. Why was it also 0? Yeah, I don't know. I need to figure this out because there's like this logic isn't right. Like, it's just not right. There are, I think, 4 possible cases that I need to cover here, and that's the trick. So what are the cases? How about that? Okay, so they're right on top of each other, and we move right. So HT is one possible case. Another case is this case, which is the simplest case. There's this case. And vice versa, this case. I think I'm just gonna, like... I think I'll just do H. Like, that's pretty clear, I think. Okay, so in this case, we just move H right. In this case, we move H and T right. In this case, we move H right, move H right, and then we have the cases where, like, move H right and snap T, or T H, move H right and snap T. Okay. So those are the situations we need to figure out. So, like, I wonder if there's a way to just figure out that they are... So what are the options? They're like, if you're staggered, then you snap. No. Yes. If you're staggered, then you snap. Okay. I think that's all it is. So it's like, if you need to determine if you're in the same column. So when you're in the same column, H moves right. If you're in different columns, but... Okay, so let's enumerate these. So same column, move right. different column, same row. So different column, same row. Both move. Different column, different row. Snap. Okay. And this is basically true for the left as well, right? Because you would be different row. Okay. And then instead of this different column, you just flip the names and everything works. So what we need to do is basically say, like, we need some way to define this stuff. But I'm not going to do this right now. So I'm just going to save this, and I'll probably finish this tomorrow when I have more time. I might not do it on stream. We'll have to see. But I need to describe these possible things and then basically create some functions for the Day9 state that basically determine their relationship. Like, are they diagonal, or are they vertical? Are they horizontal? And then are they stacked? That's what I need. I'm actually just gonna straight up delete these for now because they're just straight up wrong. And then down here, we're basically just going to say these might be right, but we're just gonna write, oh wait, no, leave this. And then these all become to-dos. I think this is right though. So the F should come second. So we're gonna move right. This is the F. And the F is going to take Day9 state to Day9 state. And it needs to know the Day9 state. Modify. Just trying to get like into a good flow here. Okay, that's better. Yeah, this is gonna hit to dos, so not a big deal. But we can kind of. Okay, this is fine. I'm done for now. Thanks for hanging out. I will catch y'all next time. Bye bye.